On June 10th, a 57-page technical report appeared on the preprint server Archive. Within days, it crossed 54,000 views. The attention came immediately because of the authors. The 14-person team from Google DeepMind included Legge, the researcher who co-founded the lab and popularized the term AGI, and Marcus Hutter, the architect of universal intelligence theory. The document opens with an unusual instruction set. It contains explicit written directions for the AI agents assumed to read and summarize the paper. It tells them which points not to compress and asks them to report, years from now, on how well these predictions aged. This choice signals a shift in the current technological moment. Frontier labs are now writing technical literature natively for machine consumption, treating AI as a primary audience for their research. This video will dismantle DeepMind's technical roadmap to superintelligence, the physical laws they admit will limit it, and the massive, deliberate blind spots they chose to leave out of the frame. Understanding this paper provides a look at the specific technical milestones and scaling metrics that frontier labs are using to coordinate their current infrastructure and investment. To understand this map, we have to move past the public conception of artificial superintelligence. Most sci-fi tropes treat ASI as a singular, extremely smart human mind operating at high speed inside a computer. This photograph shows the 2016 DeepMind challenge match, where AlphaGo defeated Lee Sedol. Systems like AlphaGo, or biology predictors like AlphaFold, are already superhuman in their specific domains. DeepMind notes that these do not qualify as true ASI. The researchers instead establish a rigorous institutional definition for what a superintelligent system actually is. This diagram illustrates their threshold. They define an artificial superintelligence as a system capable of reliably outperforming large, well-coordinated collectives of human experts across virtually all domains, sustained over a decade of work. This definition describes a system that outclasses entire human organizations and scientific institutions, rather than just an individual expert. Shifting the goalpost to institutional replacement changes the scale of economic capability and systemic risk we have to prepare for. Predicting progress after AGI is reached is a difficult, foggy problem. DeepMind senior thinkers are attempting to impose a rigid structure on that uncertainty. Their continuum plots 4 specific reference points: today's AI, human-level AGI, artificial superintelligence, and a theoretical ceiling they call universal AI. That ceiling is anchored by a formal mathematical framework known as AIXI, defining intelligence as average performance across all computable tasks. It's worth noting the self-referential nature of this choice. The report uses the author's own 2007 mathematical framework as the objective yardstick for the entire field's future. By anchoring the future of AI to their own theoretical construct, DeepMind is attempting to control the baseline definition of intelligence itself. Digital minds bypass biological limits. A model can copy its entire memory state instantly, increase its processing speed by being given more cycles, and share its learnings across thousands of parallel instances at once. These advantages widen as the raw computational power available to the models grows. To measure this growth, the report relies on a compound metric they call effective compute. Effective compute stacks 3 growth curves: cheaper hardware at 1.5x, rising investment at 2.5x, and algorithmic efficiency at 3x per year. Compounding these yields a 10x annual growth rate. Extending this through the decade results in 10,000 times more effective compute. These server racks represent the physical scale required to realize that math. Even if model quality remained at human level, that much compute could run 1,000 AGI instances today into 100 million in 5 years. At that point, the scale alone starts to look like a shift in kind. In this telling, superintelligence isn't waiting on a discovery of consciousness. It's an engineering target fueled by compounding mathematical trends and immense energy inputs. Beyond the raw engine of compute, DeepMind proposes 4 parallel routes from AGI to ASI. The first is scaling, enlarging compute and models. While this follows predictable laws, it faces a near-term wall as high-quality human text is projected to run out later this decade. The second pathway involves architectural departures. This means moving beyond standard transformer models toward things like continuous learning or neuromorphic hardware that depart from current training recipes. The third is recursive self-improvement. This is the concept of AI accelerating its own research through automated code rewriting and generating better training data. The final quadrant is multi-agent collectives. This portrays superintelligence as an emergent property of many specialized agents interacting as a coordinated hive or market-like economy. Because these four vectors run in parallel, a roadblock in one pathway is unlikely to stop the overall technological momentum toward ASI. The tech industry often describes the singularity, an assumption that the arrival of AGI causes a sudden vertical change in reality overnight. This report deliberately rejects the idea of an omniscient, omnipotent AI. The authors list hard physical and computational limits that will constrain an ASI: thermodynamics, the speed of light, the real-time pace of physical experiments, and mathematical limits like P versus NP. This diagram shows their alternative prediction. Progress will not be a sudden vertical wall, but a series of overlapping waves, where AI-enabled breakthroughs in science and the economy stack up over time. Grounding ASI in these hard physical limits turns a speculative concept into a concrete engineering problem defined by resource constraints. While the document is technically rigorous, it is also a position paper written by an organization with a direct stake in reaching this destination. Arguing that ASI is a coherent target powered by 10x a year compute growth provides the rationale for the hundreds of billions in capital and gigawatts of energy the industry is currently consuming. But the report also features a deliberate omission. It maps out compute and memory architecture while bracketing the economics, the labor transition, and the question of how thriving humans fit into the picture. The roadmap is highly detailed, yet it stops abruptly at the edge of the territory where people actually live. Frontier labs are successfully and precisely mapping the technical terrain of superintelligence while choosing to leave the human consequences blank.